Good morning, everybody. My name is Ravi. I work in Inquires in Ocean Data Management Group. So today we are in the last day of the course, and the last day is always feels happier for for all of us. So today lecture is dedicated towards the remote sensing data availability and what are the sources to get the data, the download. I have put some information regarding all the different websites where you can have this remote sensing data. During the last 4 days, we have covered the scientific materials as well as advances and why remote sensing data in oceanography is important. And today lecture is divided into two parts. First part I'm going to cover and I'm going to show you that what are the available data sources, especially in our center inquiries, and some of the useful links are also given for other international recognized websites also for your convenience. So this lecture, for my part, I will demonstrate some of the informations through PPT, and then I will also will go for a demonstration on a wave link so that you will have the feel to how to search for the required data and what are the process to get the data and this the process to move forward with your data query in this field. So Inquires is our center. Inquires is receives huge amount of data, oceanographic data. We have a many all this our sister organizations send us a large amount of data, and all the data which we receives is very useful in terms of all the aspects of geophysical science, especially physical, chemical, biological, and all the parameters. The data is we also keep in all various format like a spatial temporal data. We have all this kind of, and then we prepare data in a different data formats, different resolutions with different levels, and the data we do the pre-processing of the data. Then we do the post-processing, quality control, dissemination, archive. All this activity is actually done in our center. It inquires. So why inquires? I mean, data of inquires is useful, or it is like it's affiliated. Inquires is a dedicated center of under International Oceanographic Commissions, and it is a recognized data deposit center under International Oceanography Data Exchange Program. And also we are the part of Indian Ocean Global Observing System, where more than 70 countries all over, especially in the rim countries, we are the part of this data process and the advance in this oceanography field. So this is the information about our center. So now the classifications, what we have all possible sorts of data in form of remote sensing. We have the data from the sensors like VHR and MODIS, and then in situ we also have that Argo, then Core Argo, then BGC Argo, and CBT, XBTT. This all data we have the storage of this in situ information. Then also we have the model data, MOMS and HICOM. So these all data we have, we also process, we use, and time to time we disseminate as per the requirement. So this is just a feel to the data and the parameters. So what sensors or what buoy is giving what kind of parameters. So this slides is just for the information purpose. You can see that if you need chlorophyll, you should use that Ocean 1, Ocean 2, Ocean Z2. This information I will also going to show you in our web link how to check this data informations and their availability. For in situ, we have large amount of in situ observations also with their different parameters. So remote sensing. So now the coming to the main topic, remote sensing. So you know that remote sensing works by acquiring informations from a remote place, from a distance. So uh, uh, you already in the previous lectures, it has been pretty well explained that how this remote sensing informations and this whole paradigm work. So as you know that the data is energy reflected from the earth. This data is actually remote sensing collect the data through the energy reflected from the earth. So there is a two major form of it. That's one of the passive sensor. You can see the passive sensor has one external energy source through the data is given and by this sensor. For example, is the sea surface temperature, land, and other uh, atmospheric parameters through passive sensors. An active sensor has an energy source, and it is useful where the external source is not available, and especially in this ice area and the very dense polar regions where the natural lights is not possible, where the active sensor works. So so since the external light is not available, you can clearly see then the passive sensor will be very difficult during the extreme weather conditions to get the informations. So this is the normal remote sensing, how the sensors is divided into two broad categories. So this is some journey of remote sensing satellites and sensors. So it actually started during the first war. So to survey, do the mappings of military surveillance, and from there the kind of evolution has started of remote sensing information. So then moving forward directly in 1950s, the first space-borne satellite remote sensing, the launch by Sputnik Russia, which we call Sputnik 1, and then followed by Explorer 1 by US. Then again, during this period of 40 to 90, we have a spy satellite also been launched, and through the mapping of military use. Then 1960, we have a first meteorological satellite using remote sensing sensor is launched by US. It's called TVS 1. Then this Landsat came in 1972. Landsat satellite then have high resolutions and covering the global scale. And then this application were initially local, and then the time to time it got advanced and it become available for global scale also. So Earth observing system. So lately in 1990s, we have now the Terra and Aqua satellites. They are launched, and from that time, the sensors such as MODIS is giving us a very good sufficient amount of global coverage of required data, and which is now is available as to all of us. I mean, free access is already now available, and it's being distributed among all the scientific communities. So, and then now many advance has been done, but basically this is how this the evolution of remote sensing informations exceeded in the time. So now you have seen the remote sensing evolutions and the data. So data for all the any information received through the remote sensing satellite or sensor is remote sensing data. But what are the remote sensing products? So, and first of all, why it is we need remote sensing data and its product. So first of all, you know that remote sensing has a very good amount of coverage on Earth. So for complete Earth coverage, we need 3 satellites at a time. Means one satellite can cover 1/3 of the Earth surface. So this is a very good amount of spatial coverage of a remote sensing data. And then the places where the geographical conditions is very difficult, let's say high, very extreme high terrain region, and very polar regions where the going of human is like way extremely difficult to get the data. In that situations, remote sensing works pretty well. Then natural disasters such as cyclone, high tide, tsunami. It is very important to have the remote sensing informations to mark and understand the path of these natural disasters. And also that the natural remote sensing data is now having very high resolutions. Now even we are having in meters, they are giving the data. When we say high resolutions, means we have a very near, very smooth informations of the object it comes but through this data, remote sensing data, and hence there are various applications are available, and it can be used. Many applications you have seen during these last 4 days, how the remote sensing is very useful to identify even this the ocean color and the such processes and thermal and detection and all. So this is there are various applications available, and I have also put some of the applications which I will go through it. So data products. So what are data products? So all the informations we can different informations in a suitable and standard form and in a standard format we make and it is usually very easily available to the users. So that is the concept of data product. So data product is actually both for remote sensing and in situ data. So this is the process of doing any data products, which is because there are some many specific requirements of a user sometimes. So through this, any data processor or those who sits with the data, who can make these products through the academic, professional, or even this corporate use also. So this is how the data products are being generated. So some of the important applications of remote sensing data is coastal application. So see, coastal area is generally is a very large area. So to map the coastal erosions, understanding the coastal mapping is very useful for understand the coastal feature, coastal life, and even the transport. So such tracking is very make very easy, useful if we have a good amount of high resolution remote sensing data. Also in terms of ocean, so apart from having good amount of chlorophyll or even sea surface temperature, it is very useful in current system ocean circulation, measuring the temperature and track the float of ice sea in the polar region also. So these are the very useful advantages of having good amount of remote sensing data. Then hazard assessment is very useful to track hurricanes, earthquakes, erosion, flooding. These access natural disaster impacts and design a very preparedness strategy before and after the hazardous event. So this is a very, whenever this incident happen, hazard assessment is very useful based on the data available in remote sensing to make futures and prepare for the future, so that the future events can be and future losses can be minimized. So such information is highly useful, and this data is very useful through the remote sensing applications. Some of the natural resource management like map, wetlands and charts, wildlife habitat informations, damages that urban growth has been on environment, and help decide how to protect natural resources at best. So these are some natural information you can see even during this natural disaster such as hurricane or even it is a earthquakes, erosion. This information is highly useful. So these are the 4 major category of remote sensing data applications which is being useful in various field, by various scientific as well as governments making their plannings for disasters management and all. So such information is very useful and reliable and can be obtained through if we have a good amount of remote sensing data. So basically data products. So what are the types? And the data products has types and classifications. This is just for your normal understanding. So data we receive humongous amounts of data, so we need to process the data. So we see that whether what are the errors, available errors and all that need to be processed before making it a final and before giving to the users. and then what amount of output scales, what are the video, what are the transformation is done with the data, and the coverage area, what are the areas, and what are the even the resolutions, like how much kilometer we are giving. These things are classified into broadly in types. And the data products, so generally we say one standard data products is what we direct information which what we receive from the satellite, with a normal and necessary corrections. The corrections such as some geometrical correction we do if some lateral position has been like here and there, we fix it, and then we disseminate it or keep it in a use. So this is the standard product. The next is come is value added product. So value added product is standard product processed as per user requirements. So what some users has, let's say there's some source which is having less access on that area. So on the basis of requirement, we merge some products to make it is a more useful. So such products are categorized as a value added product. Then we have third classification as a derived product. So derived product is further accessing and through various tools, scientific tools, and making the some other products out of that validated product from the original data, such as, for example, one is that SST. So SST is, we can say, it is a derived product of the original data, either for in situ as well as for remote sensing. So this is the data, and that classification is actually distributed among these three standards. Now this slides is actually come on our this information is available based on our inquest remote sensing data centers. So if you see this part, I'm going to also demonstrate you once I finish this PPT. So if you see, we have this web page through which we will go to inquest data informations, and then we go in a remote sensing section, and then we will be prompt to a next window. On there we will have all the inputs file where we have to put the input to get a desired output. Eventually there is one open information will be available, so through which you can also see that what are the parameters is available. So I have made a flow chart of it. So if you go to inquest data and management group, so then you follow the remote sensing section. Through you have to select a product, whichever parameter you want. Then you have to select a sensor and satellite. So different sensors has a different parameters, so you have to select the sensor and satellite, and then your period, which period you want your data informations, and then you submit. So the output will be in either in a JPG image or even a GeoTIFF file. GeoTIFF file, you will have all the informations about that your data. Even the TIFF informations has the lateral positions also that you have to generate it. So this information you can have through this flowchart. So this is the same page. If you see, you have the information, like if you go here, so I have selected a parameter, let's say sea surface temperature. Then I have selected a sensor, a VHR. Then I select from which satellite I want. Then I put my date from date 1 to 30th of August 2020, and if I submitted, if you see in the right hand panel, I have a list of images. So these are my list of images on a daily basis. I have get this list of images. Now either I can have download direct image and we can use it, or if you want to do some modification or other classification, we can also download the TIFF file, GeoTIFF file. So this thing I will going to demonstrate as well, as I said. So this is how we will have this informations through inquest website. And even if some informations you want in a separate, you can always write to us on that informations regarding all the data. So I have also put some other very recognized data information centers. So first is like Meteorological and Oceanographic Satellite Data Archive Center, MOSTAC. It's an Indian deal by Indian ISRO. So we have other all kind of meteorological, even atmospheric data, remote sensing data available in this website other than the INCOIS. And then for other global scale and international scales, we have a Hadley Center, which is based UK based data center. From you will have that very large, huge amount of high resolutions ocean as well as atmospheric data. Then also we have NOAA Physical Science Laboratory. So from there you will also have some data informations, ocean, even atmospheric data, as well as oceanographic data. Then we have also NASA Global Precipitation Measure Mission, GPM. GPM mission, through which you can have just microwave data, sensor data if you want. These are the some website, and I have given the link, and I will also show you by using these links. So sometimes some of the information center, they will ask to register you before getting any data, but there is no problem with the registration. It's an easy step to do the registration. So they just want to keep a log of it. So these are the other resourceful informations about how to get the data. Now data dissemination. So data always come with a data dissemination is not a very like a simple way to give. There are many data where a policy needs to be assessed before giving it. Like there are some data has to be given before the discussion that by your demands and why you use it. So such process has to be seen before sending the data. So data acquisition and distribution of remote sensing satellite data from Indian to foreign satellite or the civilian users. Such policy, the policy makers made the such policy to how to disseminate data. Then what are the process involved for the data dissemination. So you see, if your data if you want a data, so if your data requirement is less, or let's say this training data set, that can be sent even through email. If we have a large data, we can the hard drives and DVDs can also be sent. And then now the more large amount of data, bulk of data, we use the FTP platforms, and through direct from one computer to another computer, having the access, we can transfer the data. Then through now currently many GIS platforms, web GIS platforms available. Through the internet connection, we can acquire, manage, or analyze, and even this transfer the data through one GIS platform to another GIS platform. So these are some of the steps or the path through which we send the data among the users. I have also included some of the in situ data informations for some of the users. So this is all based off INCOIS website. So this I will also going to show you. So let's say, for example, if you need some Argo validated product, so that information is given that you go home INCOIS and data information page. In situ, if you go in situ data and go to Argo, so this page will pop up. Select the validated product, and once you select the validated product, then you have to specify your time period and then your parameters. So if you see, this output will be generated. You can save this output or directly, or you can even download the NC files. So an output is available at a different depth levels also. So let's say this is information at 500 depth level. I will show that there are many different depth levels are also possible. So this is some information about in situ also. So then also we have, that we have the Moodbu information also. So in spite of not only remote sensing data, we also have very huge amount of in situ informations also. So INCOIS is provide ocean data and data products for both research and operational oceanography. Our center is dedicated center for the operational purpose also. So we also use large amount of such data. The data received from various observing system in real time at different communication system are assembled and standardized. We also design development on the open access data management, such waves tools like open layers, map servers. These are such designs and developments is being done here. Also end-to-end for end-to-end data management system is also being served here. So ocean observation system, we have a group of our sister organization NIOT who deal with mode buoy data, and all this was and then Inquis is a repository center for such mode buoy data information. So if you see, this is the Indian Ocean. So this is how connected and very dense mode, all the buoy informations covering all the Indian Ocean regions. So this is just like a glimpse of how much informations through institute is available for Indian Ocean region. So if you see the mode buoy information, so currently there are 11 to 12 active omni buoy in a particular omni buoy is available in our Indian Ocean region. So it has a high resolution real-time data. It's record both at meteorological as well as oceanographical parameters: air temperature, pressure, surface winds, radiations, rainfall, humidity. And then also surface temperature, conductivity, surface layer currents. These data parameters is available through Omni also. Okay. So, and this all, as I said, this is deployed and being maintained by an IoT, and the processing and disseminations is done here at Inquis. So if you see, I'm going to show you also this. So if you go in the selected location through Inquis web page, and if you see here the location is there, that BD14. So if you go and click on BD14, this page will prompt up. So you will able to select your parameters. I have selected ones, let's say any parameter, let's say temperature or even the air. So and then this will show you that the how much data is available. But you cannot download here. It's just for to check the availability of the data. For accessibility, you have to put a request here, and I'm going to show. I'm going to tell you that how to put that data request at Inquis. So this is information of how to see the accessibility of data information from mode buoy. So then we have a other open website called ADEP, which is also serve different type of data at a single platform. So it's a very simple, consistent data server to download subset of scientific data sets. The outputs are available in many formats such as HTML table, ASRI, ASRI, CSV, even the Google Earth, .nc, let's say their file, ODB file, text file. There is giving very flexible approach of download your output in either you want NC file or you want to image, and even it has a .png or JPG PDF format also for customized graph or map for the users. So this is also you can have we will have the access through our Inquis page also. And using for this platform, I'm going to show you. If you go here and if you see here the def home, I have given this command. So if you go to def home and go to get data set, if you click on get data set, you will have this background, and you will select any graph. Let's say I am taking this MSRE data, satellite data of that parameters. If you click it, you will be asked to prompt up in a new window. So this window look like this. So if you see, this is a global data. You have to specify your surface, then your parameter, then latitude. I set the latitude in Indian Ocean region from my north from -30 to 30, and for this is the loan is 30 to 120, and SST. So the right hand side, if you see, the image will actually pop up. So this thing will come, and then you have it for this download. You have this link here. Whatever the file type is, HTML table. This is in normally it come general type is HTML table, but if you click here, you will have options to choose either JPG, NC file, whatever based on our desire, we can download this image. And also there are some very flexibility tools are there. We can zoom our this information like two times, three times, or in out, so we can play with this picture also. So this dev is give us a very unified platform, and very more options to download this inform results in our desired uh, format. So then we have also some tropical flux parameters, so which is a very daily, timely, and accurate ARC heat and momentum flux data available in the nation region. We have a data since 1979, and this data is freely available, but for research and education purpose. But to download this data in our inquiries, registration is required, followed by a proper citations and affiliations we should provide. But not only to aspect, we should provide to all this, any data which use, we should always provide a proper affiliation that we have used this data through citations, or even the link or acknowledgement in any form. So but since we, if we receive lots of request of a data, like large amount of data, so remote sensing data and data products for the Indian Ocean region consist huge profiles. You know that remote sensing, if any high resolution remote sensing data consists huge profiles, and it is prepared and being distributed to students and researchers and whoever is required, with a proper access before disseminating it. So upon registration or request, as I said, we also send DVD containers, and in the DVD you will we will also give a explanation of how to use this through which software or user graphic interface, and similarly features for traditional web GUIs, where it is user can search, query, visualize, and download the data of their choice. For huge data, as I said, FTP platforms is very useful for transfer the desired data set. So this is a slide where you can see that the inquest data is being used by different players: academia, government, commercial, foreign, internal, total. So these are the informations. So inquest is a well recognized center. We share data among our international collaborators. We have a very good research collaborator also, through which the researcher inquest is also working through this cooperation of data transfer. Many academic activities also being held with this data. So these are the some useful uh, informations to data disseminate in different fields. So the main purpose is that if you want to use any data which is being here in inquiries, you have to put the data request through a request requisition form. So I have put a form here. So this form you have to proper fill carefully fill this form, like your name, your supervisor or PI name, why the purpose of the data, then what are the parameters, the what from which platforms, and then your duration, the purpose of research, and you should be honest about it, the purpose of your research, and it should be forwarded by the group of head of your group institution. And I have also given a link here which I will show, copy and show you. Then if you for your convenience, if you open this link, you will have this data requisition form to download and send it with your request, this form, to get the data. So our team here will access your request. If your data is something in a economical zone, then your purpose must be clear, so that the data can be given to you. So these are the informations I have put through the slide. So I'm going to stop here the slide, and I'm going to show you a demonstration of all what I have said through this slide. So I'm going to inquiries home page. So this is our inquiries home page. itu okay. Just yes, it's okay. Okay. So now this is the inquest web page. If you see, as I told, so this is our institute page. So the data, if you go in data information, these are the some Earth system portal is just being inaugurated this week by our Ministry of Earth Science. This very soon this will provide a unified platform for all the data sets from all the institute, and it will be served here. Then but for the time being, I'm going to show you the remote sensing. As I said, go to inquest data information, go to remote sensing. Okay, select it, then you will be prompt to the next window. So here we have next window. So in the very first page you have see that we have the AVHR, some product of AVHR. So if you see, this is the SST JPG. So if you, this is the recent, maybe yesterday or day before yesterday image here. So if you just click, it's a JPG product, if you just click this SST image, so the bigger picture will come up. So and the information is like here, this is the AVHR from the satellite METOP and SST product, and this is being generated in Quest ground station. So this is one of the image here. So coming back, similarly if you see here, the other NDVI is basically a vegetation index. It is showing the maximum greenness on the surface. So if you see, this is the how the other IVHR product is available in JPG. You can save it also. Then we have a fog. You can this one of the product as giving the distribution of fog in the region. So this is how. Then this is, we have that FCC. This is the false color composition. This is basically the composition of many images to generate the covering of cloud. So this is the other product. Then we have this CTT, cloud top temperature. So this will be the temperature above the cloud. These are the some product which is available at Inquest homepage on remote sensing section. So but now in a particular, if you see here, there are the other informations and your desired data if you want. So let's say if you want select a product, if you want, as I said, I have chosen, let's say I need a sea surface temperature of a specific time. So I am going to select one sensor, then a satellite, then date. So I am going to select a date, let's say July 1st and to July 2nd, and then going to submit. So say loading data, please wait. Okay, so it is now appeared. Since I put only 2 days, so it appeared very fast. If you see, the output is now right hand side. So let's see. So this is how a JPG product is came. This is the SST. Similarly, you can, if you want, you can download this GeoTIFF file. So GeoTIFF file will be definitely will be a larger file. It will be a tar file. If I'm going to click here, so if you see in my system, this TIFF file actually has been downloaded. So it's around 1 MB file. So this is how you can download these images. Similarly, I am going to see the other data. So I'm going in JPG. You see, in this image, the data is being in left hand side. In this image is data in right hand side means satellite is moving. So through this is the way to recognize your data in terms of your data position. So now, so this is like one of the aspect. Now if you want to choose another parameter, you can choose any other parameter. Let's say even in, let's say, any other chlorophyll. Similarly, you go select your satellite and sensor, your date, submit. Okay, so if they are saying no result, means you have to change time period or different satellite, different sensor. This is how you play and see the data availability. And if this and other for other informations, you can always contact with the given email ID. So now moving forward, again going in data information. So as I said, now I'm going to just quickly show you some of the other remote sensing which links which I have actually shown you in the slides. So you see here, so see this I just use this link of Hadley Center, and this page is prompt up. Now if you need any data, let's say Hadley SST, so this the data set, marine data set, and if you just click here, and this all informations, brief descriptions about the data and all information are given here. So and you can download the data, and there are some commercial and huge specifiers is given, and also some reference. If you use data, please provide this appropriate reference. So this is the other websites, and I hope I have given this other links. You can use it and check it whatever information you want. Now I'm going to show you this form, data acquisition form, the link. If you see here, if you click this link, click here to download. Please send us signed data acquisition form here. So if you download this form, fill it and send us. And for any inquiry, please contact the given person, and so that you will be directed and you will not have any other problems. Now coming back to web data services. So let's say going to some institute information. Okay, so select this institute, and let's say about any, let's say if you want Argo, I selected Argo. Okay, and then data access, you have data access, then national data center. So you will have all the other instructions. You can read all the scope, data centers and all. Floats available, floats in Indian Ocean. So this will yes, see, it's now came. These are the number of active floats available in our Indian Ocean region. So these are the some informations about available floats in Indian Ocean region. Now if you need some product, so you go on a section value added products. Okay, so this objective analysis, this product is made with a tool, scientific tool, objective analysis. So we will have a objective analysis product. So just select a time period, let's say year 2019, I selected month, let's say June, let's say temperature, and you see this product has already been there, and it's on surface 5 meter. But you can also if you can see this arrow, it will give you different value at different depth level. So the next one is 75 meters. Similarly, you can play with this depth level of 100 meters and so on. So this is the one other information. Similarly, I am going to show you that, as I said, this ADEP website. So this is the other which will take you to the other platform where you can have all this unified data information in a single page. So this is the other websites which you can use for your other data purposes. Now again, coming back, so this is the data information page from where you can play and you can check. As I said, now the top flux, if I'm going to use the top flux, this page will come up with all the necessary information. Data access, there is a left hand side panel known as called data access. If you go data access, some informations are there. Okay, you have to register or write to the person. You can see what are the products available, data files, and data access. I already told you, for data access you have to log in. So also the quality control, how all the database quality. So this information is also given in this section. If you want to read for your own interest or knowledge, you can have a look on this, all the QC manual availables. So these are the data information centers, and for even the publications which being all the publication based on the data information or given to the INQUEST from the INQUEST platform, are some informations are there. So in and all, these are very active platforms to use the data in the different fields. So with this, I am going to stop here, and if we have any query, I will take it, and then the Udaya sir will continue the final lecture. Thank you.
Good afternoon all. Let us get into that final session. Myself, Udaya Bhaskar. Some of you at the other end of the world might be knowing who would have attended our ITCO courses. Without much of introduction, let me just continue from where Ravi has left. So Ravi has shown you the sources where you can download the data, and for some of them, it requires acquisition form to be filled and sent. And for remote sensing data, somebody has already asked a question, which I have seen in the chat box. For remote sensing data, mainly, there is no restrictions at all. So you are free to download any of the data. But remote sensing data always requires it need to be accompanied by some sort of in situ. So that's the reason why Ravi has covered some of the components of in situ, like mode buoys and then Argo and other type of things. So people combine in situ as well as remote sensing and then do a lot of work. So he has shown you our website and the possible links of accessing all the data. And the other dissemination mode which we generally use is live access server. We have taken up this live access server as one of the component because it has inbuilt capabilities to do on-the-fly calculations, on-the-fly visualizations, download, and then many other functionalities. So not all people might be acquainted with using softwares for processing remote sensing data. So that's where we thought we should also come up with some mode where students can directly access the data, do whatever little analysis they want to, and then reproduce those plots in their publications or papers or their dissertation works or things like that. So that's one of the dissemination mode we have chosen for live access server. Okay, so I'll be dealing extensively with the live access server. I'll be demonstrating it to you. First, I'll show everything, the capabilities of LAS in a PPT. Then, like Ravi has done, I'll also go for a demonstration using our website. So that will complete our entire training. The first 4 days covered all aspects of oceanography, remote sensing. And then the last day, we are catering to show you how exactly the data can be used and downloaded and then things like that. So I'll be talking about accessing remote sensing data using live access server. So let me just introduce a bit about live access server. The live access server is a highly configurable web server. Web server I'm mentioning because this can be directly accessed using the web interface. And it is designed in such a way that it provides flexible access to georeferenced scientific data. So remote sensing data is mainly georeferenced. So LAS is one best tool for providing this georeferenced data. And it can present distributed data sets as a unified virtual database by using something called DOTS networking, distributed ocean data systems networking. Okay, DOTS. And some of you might be already using Ferret as one of the applications for processing oceanographic or remote sensing data sets. So this LAS is completely configured using Ferret. So Ferret is a default visualization application used by LAS, though there are many other applications like MATLAB, IDL, GRADS, and many other things. But this Ferret acts as an interface between the user who is sitting in front of the web and then at the end at the server where the data is placed. So this Ferret will do all the bulk of computations so that the user gets his desired output. The only limitation is that like it is capable of only accessing the data in .NETCF format. So if you are having some data in ASCII or CSV or some other ArcGrid or something like that, this LAS application cannot directly make you visualize the particular data. So that's a limitation. But NetCF is most sought after format nowadays in ocean and atmospheric applications. So live access server is still a pretty good application for visualizing this georeference data in the graded format. So what LAS enables us? Okay, the LAS enables a web user to visualize the data on the fly. On the fly means like just click, set the region, set the time, automatically the image is generated. That's a wonderful thing because if as a user you want to use CDAS, you have to do host of clickings and then data loading and then doing many things before you can really visualize the data. So this entire thing is eliminated. Just one simple clicks, the data can be seen directly. And also we can request a custom subset of the variables in choice of file formats. I'll show you those what are the file formats that it will enable us. Okay, custom subset. For example, if the data is there for global, but if at all somebody is interested only in say Northern Arabian Sea or near Somali region or near south of Sri Lanka. So those type of subsetting can be very easily done and the end product is directly delivered to the user. And also access background reference materials about the data. That is nothing but the metadata. So metadata like, which is the base data of a satellite for this particular data, what is the coverage, what is the lat launch, what is the time period, all those source of informations can be also accessed using this live access server. The another beautiful thing is like, compare different variables at distributed locations. Okay, because it uses dots, all the user can do is like, just call the sources, different sources, and then use LAS as a tool for comparing them. So that's one beauty. Why I call this beauty? Because the data need not be downloaded onto your respective system. Suppose you as a student in the library might not be having access to a high amount of storage. You might be having a limited storage. So in such cases, what you can do is like use a LAS and still connect to somewhere in US, one platform, somewhere in Australia, somewhere in India, and do some intercomparison. Suppose somebody wants to have a comparison between model runs and the remote sensing data of sea surface temperature. Simply connect to those servers there, use LAS and do a simple intercomparison and then use that output. So that's the beauty of the live access server. So what it enables the data provider, what it does is it unifies the access to multiple types of data in single interface. Multiple types here means, for example, you want to compare or use wind data, SST data, rain data, fog data, or something like that. You are doing some application where all these things are required. So you can unify all of them into a single interface and do some sort of intercomparison. So that it will allow. And create thematic data servers from distributed data sources. I already mentioned an example of model as well as remote sensing. So it can say, for example, thematic means here sea surface temperature is one theme that you are thinking of. So want to compare between model as well as remote sensing as well as in situ. So all these three different types of themes can be used and intercomparisons can be done. And offer derived products on the fly. On the fly, as I told, just click, do some sort of multiplication. Say, for example, RSS website provides the data in a string format because to save the space. So it will give values between 0 and 255. So the value shows with a color bar of 0 to 255, but that is not a real SST. All you can do is like use the live access server, do the multiplication of this particular value into 0.15 minus some 15. Some simple equation is provided by RSS website where you can automatically convert that value there into your desired SST value. So it can automatically do that derived products on the fly. Just use that application there and then enter your equation, and then automatically the output will be generated where you can visualize it. Such simple things can be done. And metadata already I have answered. And offer unique products. For example, different visualization styles also you can do it. Somebody wants with a filled land, somebody wants with blank land, somebody wants it to be the blank regions to be interpolated and filled. So many different types of unique products can be generated using this live access server. So now with this few capabilities of live access server, let me go over the overview of the live access server just to get a feel what all the functionalities that live access server provides to the user, particularly in terms of remote sensing data. So I have chosen all my slides to depict that of examples of remote sensing because the courses we are covering here is mainly of remote sensing. Okay, but the capabilities can be extended to anything beyond remote sensing, that is for in situ. For example, there can be a gridded data from in situ observations like Argo, temperature, salinity, and things like that, or some flux data sets from the mooring. So many other formats also you can use LAS to visualize, do the analysis, and then download them in the format of your choice. So this is the web page where we are hosting our data. If you just open any web browser and then say type las.inquise.gov.in and then just enter, you will come to the home page of our live access server. Okay. So once you open the home page, there is a button called datasets. If you choose the datasets, it will open up a page showing all the host of the products that we are making available on our LAS. So if you see, we are making AMSRE ocean datasets daily and 3-day average, and then monthly products and products from the Argo, and this ASCII data, ASCII data mainly for the winds, and data products from our ground station are also made available. What all have been taught in the previous classes by Dr. Srinivas, Dr. Anish, and all those. So those ocean color products and then AMSRE products and TMA products and all those things are all made available here. And we also have created some sort of climatologies from these data sets. So those things are also there. So NOAA high resolution SST, you all know that some of the passes from the ground station might be having gaps owing to some clouds or sun glint and things like that. So NOAA has come up with some graded products where it's a high resolution SST where all these gaps are eliminated. So those things are also we are making available in our live access server so that people can use for their research applications. And then some objectively analyzed fluxes data, which Ravi has already shown you. Ocean analysis is our model outputs, which we use for people to see. And then ocean color monitoring, OCM1 and OCM2. Both chlorophyll datasets are also made available. QuickSCAT datasets are available in TMA ocean datasets. So if you can see, majority of the datasets that we are making available through our live access server are all remote sensing data. Because remote sensing is generally in the gridded format, and then live access server supports mainly a regular grid datasets in NetCDA format. So we have chosen LAS as one of the means of disseminating data and also one of the means for students to do their analysis, visualization, and then download and then use for the respective. So that's best source for dissemination. So from the previous slide, if somebody has chosen and then click the button AMSRE ocean datasets, so it just opens up further more details of the data. This is what we are mentioning in the beginning slides as metadata. So it is giving much more details about the ocean data, AMS array data sets. So there are two options for the user. One is the 3-day composite data. The other is the monthly composite data. Okay. If you, as a user, clicks the 3-day composite, it further opens up to show what are all the parameters that are available in this particular data set. So it hosts cloud liquid water, rain rate, sea surface temperature, surface winds, and atmospheric water vapor. So these are the 5 parameters that SSMI or RSS website makes available to us. So the same thing we have been uploading onto our live access server for user to use it. Okay. And if somebody is interested in the monthly data sets, obviously you just have to click on the monthly. Automatically it opens up the same type of variables for the monthly products instead of 3-day composites. Okay. So let us go forward. So in the previous slide, what I have done is I have opened up the 3-day composite and then checked or chosen sea surface temperature. So once the user uses this radio button and then say automatically the data is plotted here. So this is what called on the fly data visualization and data generation. So what it does is like simply just fetch the data from our server here and then it displayed. So as a student, if at all you are using on sea surface temperature, trying to analyze the data, you need not bother about downloading the data, processing the data, and then trying to understand the format, trying to learn a software for visualizing the data and all that. You can simply use live access server and see how simply in a matter of 2 clicks, the entire plot is generated. So if you see on the left side, this is the bounding box showing the data availability for this region. We have made sure this data is available only for Indian Ocean region because mainly we are concentrating from our center in the Indian Ocean only. But of course, we have many other data sets which are covering the global area also. For example, all our model outputs are covering the global, and even some other products, fluxes are also for the global, and some wave parameters also for global. So there are many other things for global. But some of the requests that we initially got is mainly for Indian Ocean. So we started to concentrate on the Indian Ocean. If there is a huge request for global coverage, we are happy to even move to global region also. So this is the bounding box showing like the data availability for this particular region. Here it shows 4 boxes where the user can do or give his region of choice for subsetting. And also there are a host of options here available. Here what is shown on the right side is it's called XY plot or longitude latitude map. So directly we can get SST for that particular single timestamp here, that is say June 2011. Somebody wants to check for a hormonal plots, how it is varying or latitude or how it is varying or longitude. The user can choose those things here and just simply give those longitude value or a latitude value. I hope people are familiar with hormonal plots. It is generally used to study, for example, plots to show how the variability is along latitudes. For example, Rossby wave propagations or Kelvin wave propagation type of things. Somebody wants to study, then definitely he has to plot this hormonal plots. And also there are a host of line plots that user can use. For example, a time series plot, just click at one location somewhere here of your choice, and automatically for the entire available time period, the time series plots will be generated. In the demonstration, maybe I'll cover some of these things. So along longitude, if somebody wants to know how the things vary from east to west or west to east, so draw a line along east to west, automatically it will show you a line plot showing how the variability of SST is there. Somebody wants to know the variability along latitude from south to north also, he can choose that line along south-north and automatically the plot is generated. Scatter plot, since we have seen in the previous slide, there are parameters like wind and then sea surface temperature. Somebody wants to do the study to see what is the influence of wind on sea surface temperature. You can directly go here and then go for property. It's called a scatter plot. So directly choose that and choose the parameters. It automatically generates a scatter plot for you. So you can see host of those type of analysis is made available on the web itself without even trying to learn any software. For example, people need not know the ferret at all to understand and plot these things. As a user, if at all you want to do this, all these things ferret, you have to first know how to install ferret, how to load the data sets, what are the type of commands that people have to give to generate this type of plots and all that. So that all those things have been eliminated. So it's simply serving the data on the fly. So that's why we have chosen LAS as one of the main applications for hosting our data and then delivering our data. Okay, let us move forward. So if this with simple entire bounding box, it is shown that live access server has projected this particular plot. Suppose somebody wants to do some sort of subsetting, say for example, Arabian Sea. How simply the user can do, just simply draw a box with your mouse with this particular region, and automatically it will generate that subset. See, within this is a previous plot where the user has chosen, this is the bounding box for this region of his interest, and the moment just leave the mouse, automatically the entire region is enhanced, and then this zoomed version of this particular region is shown. So that's the reason why it's called on-the-fly generation of the plots using live access server. So the same time step, you can see like, the region is automatically, entire bounding box has changed to the small subset here. So that is the area the user has chosen. So that simple step it creates, and then user can do the subsetting. So coming to the functionalities, what previously showed is just a tip of the iceberg. There are so many other functionalities in live access server. So if you go back here and then see on the top, so these are all the top bar shows the different functionalities available. So that I just zoomed here and then kept. So it has got options like choose datasets. You can choose the host of the datasets that we have shown in the beginning, and update a plot. So the moment you do a subsetting and all that, you just have to say update the plot, automatically the plot will be updated. So that's the option for update plot. And set plot options. I'll show you some of the examples. Previous here, the land portion is blank, appearing blank. Suppose somebody wants it to be filled. So these are called plot options. So the user can set the plot option such a way that like fill land and then no filling land, graticule settings. See, for example, these are all the gridded lines which are there. So this we call a graticule. If somebody feels this is annoying for the eye, you can remove the graticule, and so these are all different plot options that the user can set. So many of them are there. You can animate, provided the file size is small, it will take the animation within no time. But if the file size is too large, you may have to wait for some time for it to cache the entire data and then let it animate for you. But animation is simply there. So you can download it as an animated GIF and use it in your presentations while you're making a scientific presentations to your supervisors or at some conferences and all that. You can use this animated plot without any big difficulty using live access server. You can, as I told, compare. You can do two different comparisons, choose different plots and then do the comparison. If somebody is interested to use this output on the Google Earth, you can also export this because there's an option for it to generate a KMZ file and then export it into the Google Earth. You can show value. Suppose somebody is interested in a small region at a location. What is the value there? Instead of going for this entire maps, you can just ask it to show the value. It will show the value and export it to the desktop applications. There's so many hosts of them are there. I'll show you examples. And you can save the files in different formats. And then you can use this as link in dots. And then you can also print it. So many options are there in the live access server for remote sensing data. So select the plot option. Now let us go for choose datasets. We have already chosen datasets in the previous slides. You have seen it. Update plot as yes, you have seen it because the moment you subset it, it has updated the plot. So that updated plot option is also checked. And now from the set plot option also onwards, we will see how the LAS will provide these capabilities to us. Okay, so set plot option, when you click on the set plot option, it will open up this dialog box where you can say evaluate expression. As I told, you can give the expression so that suppose you want to multiply the SST value by say 0.1 or 0.2 for some reason. I'm just telling off the track. I'm just mentioning it need not be an exact thing. So when you want to enhance the value and then suppose this entire map has got a bias of 0.5, you want to eliminate the bias or you want to plot it removing the bias. So then you can just evaluate an expression here, say SST minus 0.5. So automatically the expression will be evaluated and then new plot will be generated here. So interpolate to the normal plot. Right now it is off. You can make it on so that those white patches on and all those things can be eliminated by interpolation. So image format, you can set it to GIF and other type of formats. Plot size default. If at all you want to increase, you can increase the plot size. Margins, degrees, minutes, instead of degrees, if at all you want minutes and all that. So those type of things also can be used there. Palette is nothing but the color option there. There's so many different options of available with Ferret. Almost like 20-30 palette options are there. Sea blue, that means only blue color from low blue color to high blue. Land sea option, that means brown and blue combinations because land is brown, blue is ocean is blue. So those type of different palette combinations are there. Suppose somebody cannot afford to go for publications using color. There is a grayscale option is also there. So all that they have to do is like set a grayscale, print the plots and use it in their publication so that they need not pay their publication charges for those color plots. And then you can change these fill levels, color levels. You can just, instead of say for example you want to see only SST value greater than 28, so you can set those values here. Okay, contour style, and you can line contours you want, or only the fill contours you want. So many other options are there. All these things, as I told, without learning any software, the user can just simply click and then get the outputs of his desired location. One example I have just shown here is I want to go for fill LAN instead of the white patches. Okay, so I'm just going for LAN fill style default. Instead of that, I go for fill. The moment I just check it, you can see the earlier map. I'll just show you the previous. See, if you see here, it is with those white patch. But as a user, I want this to be filled with LAN so that it's a gray color. So automatically, see, the moment I choose gray color as the option for LAN filling, it is filled. Just like that, again, it just sent you the output without much of any difficulty. So that's one of the beauty of the live access server. So I set the option called LAN fill. Automatically, I got the fill option here. Okay, so let us move forward. So animate. So a user can, as I told, the user can choose the parameter of his choice and then automatically ask it to animate. I have chosen an MLD frame topology here because it has got 12 timestamps only, so that it will do the animation much faster. So once the user chooses that, this is a static page, that's why it is not showing the animation here. Here below options it will say, if you say loop, it will loop continuously, so that like January to December, how it is varying, the user can see, and it will keep on going. Suppose if you want loop once, loop 10 times, loop 2 times, those type of things all can be set here. And then you can move forward, play, stop, speed also you can set here. So all those options can be set, and this can be directly used by the user in his research applications and presentations. Okay, so remote sensing data can also be happily used for animations and all. Suppose one example of this I'll give you. Somebody knows that a cyclone has, or depression has started on say 15th of July, and then the cyclone has become into a super cyclone, and then over a period it has dissipated. So say 15th to 25th is the period of the cyclone passes. Somebody wants to animate the period and then see how the SST is varying or how the wind is varying. All he can do is like choose this particular data for the periods at 15th July to 25th July, SST for the region of his choice, and then say animate. Automatically the entire thing can be animating. So that's a beauty. Like you need not do any exercise for this. Simply choose that region of your choice, the period of your choice, and ask it to animate. It will animate. So you will know how much SST drop is there, how much of other parameters variability is there during this particular cyclone passes. So those type of things can be animated, and then you can use it for writing your papers. Or with this animation, if somebody is seeing there's a drop of 2 degrees SST, you can directly quote in your text that like a 2 degree SST drop is seen from the day of the cyclone formation to the dissipation day. So those type of all those outputs can be automatically done using this live access server. So this is the compare plot which I'm telling. There are options for multiple plots, like 2 plots you can do, 4 plots you can do. So here I have chosen an option for 4 plots. So all the user can do is like, here I have taken example of again sea surface temperature. See, if you can see here, I just chosen the same month, 1st June, 4 different years, how the SST is varying if somebody wants to know. Here it is 2008 June 1st, 2009 June 1st, 2010 June 1st, and then 2011 June 1st. Okay, you can see intercomparison how the SST is varying for 4 different years for the same day. So this type of comparative plot also can be done. People need not stick to SST. I can open the same day, here SST, here wind, here rainfall, here some ocean color. Suppose you can see like there is a depression here, SST is dropping, the winds are intensifying, and there is a rain there, and there is a chlorophyll bloom there. So these type of intercomparison plot also can be done using the live access server. All the remote sensing data in one single nutshell, we are keeping at one place and then doing all the analysis in a single go. So that's one of the applications of the live access server. As I told, if somebody is interested, because Google Earth, the feel of the pictures are really good. So if somebody wants to generate a KMZ file and then project it onto the Google Earth, and then that they want to use it in their presentations. So the readily available applications is there. You just have to export this entire thing as a KML file. See here, when the user chooses that, automatically it is asking, do you want to save this file? And then just give the location. You can just say save. It will go to default. Your file download option will be there. There is a download folder will be there in each of your systems. So it will be downloading there. So once you download, if Google Earth is installed, remember this, Google Earth should be installed in your system. Otherwise, this KMZ file cannot be viewed. Okay. So if it is installed in your system, just right click and then say open in Google Earth. Automatically, you can see such type of beautiful exporting has happened. So again, here, no amount of exercise has been done by the user at all. All he has done is he has used the live access server, saved the file as a KML file, and then exported onto the Google Earth. So directly the visualization can be done. All the other properties of Google Earth, like rotating, zooming out, all those things can be again done with this particular KML file, because the KML file is the one that will enable the user to do all these things. Okay, so this simple on-the-fly application can be used. Again, last Google Earth combination, these plots can be generated. So the other option that user is given is like export to desktop application. Okay, so in what all formats it can be exported is like it can be exported as a MATLAB script or a Ferret script. As I told, Ferret is the acting as the interface between the user and the server, and then doing all this exercise for us. So if some of you are familiar with Ferret and you want to know what is the commands that are being written in Ferret for this particular application, are generating these plots and all that. So it will ask you to export to Ferret. Automatically, it will generate your Ferret JNL files. And if at all you are using grads, it will export to the grad CTL files. You can directly open that particular dataset in your grad CTL files. And if at all somebody is using an OpenDAP URL, okay, Open Data Access Protocol and URL, it will directly give you that OpenDAP URL so that you can directly use that URL in your respective applications. Okay. And the other option it gives the user is as save as. So if at all somebody wants to save the data, where all it can be, what all formats it can be used is like NetCDF formats. Okay, as I told, NetCDF is one of the most sought after format in our Earth Sciences field. So the first option given is NetCDF, and if somebody is willing to save this data in the ASCII format, also it provides an option to download it and save as an ASCII format. And if you are familiar in CSV, comma separated value, so those CSV format also can be given. And if some of you are familiar with ArcGIS and ArcGrid and all that, so ArcGrid is the option given. So this also can be saved. So once you save, it's up to you to use this particular saved file in the respective applications where you want. Suppose a user familiar with NetCDF, obviously he'll download the data in the NetCDF format so that he can directly use it in Ferret, or if he is knowing MATLAB, he can call it in MATLAB and do his application. If somebody wants it in ASCII because he wants to use it in XLS format and then do some sort of plotting and all, because he's familiar with only ASCII, he can directly download data sets in ASCII. Same as with CSV also. And if somebody is familiar with GIS, open source or commercial softwares like S3 and things like that, he can directly download the particular data in the ArcGrid and then start using the data in that particular respective format. Okay. The other source was, as I told, the last one is the OpenDAP URL link, which is shown here. So if OpenDAP link of the live access server, all the people can do is directly go to the OpenDAP link there and then just click on any of them. There's so many data sets. For each of the data that is there on the live access server, there is a respective link in the OpenDAP. Okay, just click on the link. Automatically, it will open up the respective link or the URL in terms of the OpenDAP. Here you can see threads dot slash ocean atlas subset and the ocean.jnl. So this is the entire link for this particular data. Click on that further. It will tell you that data URL. So it directly give you the HTTP last inquiry regarding slash threaded, so many, all that will be there .jnl. Okay, and it gives you all the metadata details of this particular data here. For example, here it is telling like the X value starts at 20.5. The direction is I. In Ferret, IJK and L corresponds to longitude, latitude, depth, and then time. So That's why it is telling the direction is below. I just cut it, but you can just see same thing for Y. It will tell you where it starts. Starts, let's say minus 30 south or 30 south, and then it will tell you direction is J. And then since there is no depth, and this is remote sensing data means only surface. We don't have any data corresponds to the subsurface. That's where there will be no Z value. And T value, it will tell you what is the corresponding time. I think we have chosen 1st June 2008 or something like that. So it will show you that particular time there, and it will tell you the direction is L. So IJKL. So those type of directions it is giving. If any of you are familiar with Ferret software, and if at all you want to use this data directly without saving, what I can tell you is just copy this link at the data URL. Just copy this and then open your Ferret software by giving Ferret, and then it will give you the S prompt, yes and question mark prompt. After that, use space within quotations. Just copy this URL, and then what it happens is directly it will make this particular data set available for you. The beauty is the data is not downloaded on your local server. For an example, I'll give you this data set corresponding to the TMI is almost like 20 GB. So imagine if at all you have to work with the sea surface temperature of TMI satellite and you want to download data, you have to allocate a space of 20 GB on your system. But using this OpenDAP link, without copying this data, you are directly accessing the data and then doing the host of applications that you would like to do. So that's the beauty. Use this link directly and then do all the plotting which I told you. You can do subsetting, you can do extra new expressions you can create, change the color plots, change the style of the color plot. So many options you can do without even downloading the data. So that's the beauty of your live access server. So these are some of the statistics that we have kept. Just want to show you that, like, there are really people from all the countries using our live access server and then trying to access the data. You can this keeps on updating as and when people from different countries are accessing. You can see many people from the US are accessing this. Other countries it mainly corresponds to the internal user of Incois because they don't have any specific country associated. That's why these are all our internal people. Also, you can see many people from our own organization themselves are trying to use the OpenDAP links and then trying to access this data. The URL, as I told in the beginning, is last.incois.gov.in, and all the hosts of remote sensing data, which our colleagues in the previous classes told you is made available there. And also the other sources which Ravi was mentioning before me, those things also can be accessed using this live access server. In case you want to contact us for any of these queries related to live access server, not just live access server, for any other things related to the data, you can contact us using the dmg@incois.gov.in. Directly we'll be responding to you. Ours is the Data Information Management Group. Now it is reformed as Ocean Data Management Group. Okay, you can directly write to us and then get replies with respect to the data. Okay, thank you. I'll just go back to the demonstration. Meanwhile, any queries that you have, please type in the chat box and I'll be answering at the end of this particular demonstration. Okay. So open any web page and directly go and then say las.incois.gov.in. Say enter. Okay, so it is opening the LAS server, that user interface. You can see all those things which I talked about right now. It is all there here. Okay. So default, what we set is like there's an option for making one of the specific data sets as default when a user opens the live access server. So what we set is out of popular interest, we have made sea surface temperature from AVHR or AMSC combined, which is being provided by NOVA as our default projection base. So the moment it opens, it just goes back to the first timestamp available with this particular data, and then the plot is also shown there. So you can see on the left panel what I was showing you earlier. So here is the data set link. So if you just click on the data set, you can see that Argo data product, ASCAT data, MEMET tool, microwave data sets, and then NOVA high resolution SST and ocean analysis from our modeling, ocean color products, OSCAT wins, QuickSCAT data products, and so many other. So as I told in the beginning, this we generally use to disseminate majority of our remote sensing data sets. So let us go back to one of those, choosing was one of those data sets. So I'm just choosing again NOVA high resolution SST. If I just click this button, it just shows you there are two options. One is AVHRR and AMSR, a combined product is there. The other is only AVHRR products. So let us go to AVHRR products because that is what has been already taught to all of you in the previous classes, and our ground station also gives you AVHRR data set. So if you just click on the AVHRR, it is telling you there are two variables in this, that is daily sea surface temperature and daily sea surface temperature anomalies. Anomalies, I think most of you know, that is the mean for all the time periods have been removed from this respect to individual timestamps. So the mean is removed, then it becomes a anomalous plots. So these two are available. So I'm just choosing, say, remote sensing daily sea surface temperature. So that is nothing but what is already there in the default here. Okay, so default it is showing that it is corresponds to 1st June 2002. Okay, here when I change any choice of any data sets, the user first have to say update the plot. Okay, the moment say update the plot, you can see that it has updated, and then the corresponding timestamp has moved to 1st September 1981. Okay, if at all I want to do another choice, so let us click this checkbox, say update plot, so that you need not press this update plot button every time. So once you check that, anytime you go for a new option, default it automatically refreshes the page. So here I'm just for the same day, instead of sea surface temperature, suppose I want to plot sea surface temperature anomaly. There's a drop down box here. Just choose this second option, and you can see automatically the anomalous plots will be coming. Okay, if the resolution is too high, sometimes it may take some time, but otherwise generally it will be pretty fast. So this is the anomaly plot or sea surface temperature for the same day, that is 1st September 1981. Okay, let us go back to sea surface temperature and then choose a different timestamp. So instead of 1981, I'm just choosing, say, 19th April 2010. So you can see here it shows like it's updating. So this is the sea surface temperature corresponding to the 19th April 2010. I think you're able to see the beauty in the sense like, just on the fly, just on the click, the entire data is being processed and then disseminated to the user directly. Okay. If at all somebody wants to know the details of this particular data, there is a question mark here. So just click on that, automatically it will just open up and show you the full details of this particular data. This is the open tab I'm just talking about. Description, you can see this is the metadata of the corresponding parameter that we have chosen, or the data that we have chosen. That is daily sea surface temperature. The range X range is 20.125 to 139.88. Y range is like -29 to 29. Z range, as I told, since it's remote sensing data, only surface will be covered. There is no depth range. That's why it's given as 0. And time range, it is also given here as 1st September 1981 to 10th July 2021. Okay, and the units of this particular data is in Celsius. So this is the metadata corresponding to the data that is there. So that's one beauty with LAS, that it gives the full range of details. If I further click on the C URL, then again it will give you the LAS URL here. This is what I'm trying to talk about. So if we just click here, it will give you further, open up a new page where it will give you further details, which I showed you in the in the PPT. Okay, so this is about the metadata, and let us go back and see the applications of this particular live access server. So as I told you here, if you just scroll down and want to do a subsetting, somebody wants to do analysis correspond to the Red Sea or Persian Gulf, whichever region. So I'm just going for the Red Sea. So there are two ways. The user can provide those latitude longitude values in the box provided here. Automatically it will do. Suppose you are not familiar with that particular option, so just go here and then choose a box, draw a box here. That's it. You are able to see left side automatically the values corresponding to those text boxes are also varying. So just I'll choose here and just leave. You can see automatically the plot has been modified only reflecting the Red Sea. Okay, we have not done anything much big thing here, just chosen it and then subsetting has happened. So you can also see the corresponding values of this particular box is also there here. Got it? So let us go back to the full extent. If at all you want to get it, there is one button here. If you just click on the top, it will go back to the full extent. I think you're able to see here there are a host of buttons which will control the figures. I just clicked on the second button on the top, which will tell reset the map. So it has, from the Red Sea, it has reset the map to the original extent here. Okay, let us also go to the other plot options. As I told, line plots, I just want to go for a time series. Say, if I click here, automatically it will tell you. See, the moment I choose time here, it is asking for a start date and the end date. So if I say start date is 1st September 1981, and then I'll go for a few years because I will take quite a long time. Say 12th March 1983. You can see automatically the line plot has come. Okay, such a hassle-free software, hassle-free application that the user can directly get it. Okay. Earlier one is a spatial plot, and this one is a sea surface temperature corresponding to the location. So which location you want to get it? See, this is a circle which shows this line plot is corresponding to this particular location. Suppose you want to change the location to something else. Okay, automatically it will change to the corresponding location. Instead of 0 degrees north, I'm saying say 15 degrees north. You're able to see right side how it is varying. So instead of this is say 65. So now the point is Central Arabian Sea. So you can see Central Arabian Sea automatically the values have changed. So this is so simple. That's why it's called on the fly generation of plots using live access server. So let us go for longitude. Okay, the moment you choose, it will be having something default. So this is the wedge along which you are now seeing the values of SST variability for the time period or for the particular date, that is 19th April 2010. Similar way, if you choose latitude, automatically it is showing in the Arabian Sea latitude. Okay, somewhere in the 5 degrees north to 22 degrees north or something like that. So that's the region where it is showing. All those metadata will be there here. Okay, what corresponds, what is the variable that you are choosing, which longitude, along which longitude that you are viewing the data, and then the time corresponds to that, depth corresponds, all that will be there. So the plot is automatically updated. So you're able to see, I think it is refreshing so fast, getting new plots, and then these all can be used in your exercises. Let me also show an example of a Haumala plot, which I'm talking about, the propagation of Rossby waves and all that I'm just saying. Here we can see SST variability. Okay, so just a small time period is taken. I think which time to which time it is taken. This is 1981 1st September to 12th March 1983. Some 3 years which are chosen earlier. The same place it has chosen. So what does this Haumala plot represent? It shows you about the seasonal variabilities. So clearly you can see that this region, what it corresponds to, this is the one. This is the wedge is shown here. So somewhere in the Arabian Sea. So Arabian Sea, this portion experiences high SST during May, March, April, May, and again during October, November. So like this, if you increase the number of years also, you can see clearly the seasonal variabilities each year, how those things are varying. So that one get an idea of the seasonal variability. So that's one of the applications of Haumala plots. So same way you can also go for a latitudinal plot also. We'll see how it varies. So this also along the latitude. Okay. So here also you can see along March, April, May, or April, May, you are getting high SSTs. Again, the second highest is you are getting somewhere in October. Okay, previous year also October it is shown here. So you can see all seasons whether the same thing is being repeated or not. And it is a winter for this particular period during November, December, January. Again, winter for this particular period during December, November, December, January. So these type of things can all be seen from the remote sensing data using this live access server. So now let us get back to the full data set. and then see the other applications where we are. Let us go back. I'm choosing longitude latitude map. So directly we got this. Okay. Now, as I told, animate option will be there, correlation view will be there. Let me show you some sample applications for instead of one plot, I'm seeing for compare two plots. Okay, plot options. If I say update, automatically it will update and then show you. Just a minute, it will take some time to open those two images. Sometimes if your choice is too large a period, that is the type of applications that it will show you. Okay. Fine. So here now I have chosen two plots. That's why you're able to get two plot options here. Imagine if somebody has to do this using one of the known GIS or somewhere. So you have to open two different layers, and then first layer you have to call the data, second layer you have to call the data, and then load it, projections checking, so many things you have to do. Here you are not doing anything at all. All that you are just told is just I want two types of plots, two plots for comparison. So here it is showing the same default. What it will do is it will replicate the existing plot into two components. That is sea surface temperature for 19th April and same thing for 19th April here. All we can do is suppose I want to compare 19th April instead of 2010. I want to compare the same date for another year. So I'll just go down and then say 19th April 2012. Okay, some sample. I'm just not able to control this. So the moment I choose a different date, so you can see directly comparison can be done. Okay, without much of any big analysis. So like this, you can also go for compare plot instead of 2. You can go for 4 compare plots. Wait for a few seconds. That automatically updates. Okay, so if it is taking some time, generally the live access server will give you a message like this for saying please wait or exit, whichever one. So if at all it is taking too long, better to exit. But if it is generally takes few not more than few minutes. So here also you can see it is done within a minute or less than a minute. So here, like earlier I showed you 2 comparative plots. Here now it is 4 comparative plots. So the user can go back to comparing SST with wind, with other type of things and all that. Okay, so here we suppose this one instead of sea surface temperature, I want to go for sea surface temperature anomaly. So to do the comparison with that, same way you can choose a different plot here. So here you can you can see the day and then corresponding anomaly has come, and down also you can choose a different timestamp altogether. And then say, for example, here also different timestamp, and either you want SST or it's anomaly. Whichever one you want, you can just choose it. Automatically the plots will be updated. So the beauty you're able to see, I think, automatic updation of the plots, on the fly generation of the plots without any much of a analysis. Only thing the framework is set, the users are automatically choosing it. So you can see 4 comparative plots are there, and then you can do all those comparative analysis. Okay, let us get back to a single, only one plot now. So it has come back. Now, as I shown you an example earlier, go for plot options. Plot options, let me go for landfill style. Okay, filled. If I say okay, you can see it is doing the analysis and it will fill it. As I told you, if the request sometimes taking long time, it will give you a response saying like, no, it is taking some time because it has to do the analysis. It has to touch the server and then run the JNL file and then get that image back and then project it onto the web. So it does come back. So see, earlier it was a blank, here it's a white, but as a user somebody wants to, I don't want all those white patches for that land. So instead, if at all you want the grayscale, automatically it is filled with the grayscale. So this is one option, and a user wants to do some contouring also. This is only a plain options are there. Say for example, contour, color style, color fill and lines, only lines, raster, and so many options are there. So if I say instead of color fill, and I'm choosing color filled and line, if I say OK, you can see you will be getting the line contours also along with this filled options. Similarly, the options for filling the graticules to be removed, all those gridded lines. Many options are there. The user have to just preset it and then say run it. If your net connection is pretty fast and your choice of your resolution is small, it will not take much time. See here. So earlier it's only just a fill contour, but now fill contour with those line contours also there. You can see the values 30.5, 30, and all those type of things have been filled. So this is the power of GLASS, where the user just have to fill the requirements and then ask it to generate. It automatically generates, and then he can use it as and when he wants in his application. There's so many ways of using this particular data also. I'm not going through the entire thing. I encourage all of you to just go about this live access server. All the remote sensing data sets which have been projected by our colleagues are all there here. Please use it. There is no restriction on use of this remote sensing data. There was one question by one of the participants. I have answered also. With respect to the remote sensing data, there is no restriction at all. You can download anything. You can use in any format to any coast, anywhere you want. No restriction of EEZ or anything like that. But if at all you want to combine this remote sensing with any of the in situ data sets, which some of them has been projected by Ravi, there only the data restrictions can be applied. Mainly in the EZ, we don't support giving data in the EZ to non-Indian nationals. And for other IMC data also, we just have to get the required filled in form, and then it can be supplied without any problem at all for the research purpose. So I have not installed Google Earth in my system, so I'm not showing the Google Earth option here. I'll just show you the save as options. So the moment I just press save as, automatically it will go back to another page where it will tell you what are the formats. So it is telling the longitude, latitude, range, all those things are there. It is telling. So here options are there, whether you want to save in terms of NetCDF, ASCII, CSV, or grid. These are the four options. Obviously, one of those things. I'm just say choosing NetCDF, and then time period. Say 19th April to say 30th April somewhere. I'm just so 30th April 2010. So this is the time period I have taken. The moment I say save, it has, see, you're able to see it downloads the NetCDF file in your download directory. I'll just show you, go back to the downloads here. So downloads. So this is the file that BA underscore ferret and things like that. You can see this is a NetCDF file. Just now it's 1246 time. You can see, he can rename it here and then use this in any of your applications, like for example, MATLAB or Ferret or wherever you want to use that. Okay. And the other options are also like, print option is also there for this. So print option, it is given in terms of this, that picture, whatever it has come here. So this is what I'm telling. All the user had to do is like, directly use this page for printing or save as options are there. So directly use it in your thesis or directly use it in your presentations. So link also can be given. As I told, links is nothing but this entire, you can go back to that opened app link also. The same thing will be there. Otherwise also through this link also can be used for your applications. Animate, as I told, all this time periods are quite large, so that I'm not going to check in. Let me see. I'll just go for animate options here. The time steps. Okay. If I say it'll, if I choose a huge data set, it will take a lot of time. So that's why let me see for a small time. Okay, it has come. So 19th April to 10th July, instead of that, I'll just choose if I choose just a 10 days or something like that. So 19th April 2010 to say 20th April or 30th April 2010. This 2011. It's too large. So let me choose. Okay, 17th June, I'm just saying. Submit. It will take some time, but then immediately start animating. You're able to see here that it is trying to animate now. Each frame it is showing here. I hope you are able to see that. Once it will cache the entire thing, it will do a animation very fast. I just want to take only 10 days, but yeah, it's 27th April. So I think you're able to see now that it is showing the entire frame is changing. So once the entire data sets have been chosen, automatically it will go for the things pretty faster. This you can save as animated GIF option is also there. Here the options of looping are there, as I told you. Loop, let it finish. I think it's caching. So that's why it's taking some time. So once that option is done, so let us go to the previous, meanwhile let it cache. Okay, so this is the plots, and then animate we have seen correlation viewer. You can choose two different, as I told, Google Earth I have not installed in my system here, so I don't want to go for. Otherwise, you can directly go for Google Earth. It will generate your KMZ files. Let me see if at all you can go for. If I say OK, automatically it will give you the option for. See, the KMZ file has been KML file has been downloaded here. So this can be used in your Google Earth, and automatically the plots will be generated. And then show values, as I told, show values will tell you expression or default, interpolate, don't interpolate, and all that. So this can be done here. And then you see, these are the show values, means it will give you the corresponding ASCII values. So if somebody is comfortable with ASCII values, it will automatically give you those. Here dot dot dot, here the 4 dots all corresponds to the land. Okay, the rest of the places where there is a valid value, it is showing the valid value there. Okay, and export desktop applications, this we have already seen, and save as also you have seen that we have saved the sample file as a .NET-CDF file. So these are all those applications that LAS can provide with respect to the remote sensing data. Okay, I request all of you to work more on this. Let me see if the animation has been finished or not. I think it's still going on. Yeah, so now it has buffered everything. I hope you are all able to see that the full-fledged animation is happening. Okay, so you can also see that all those frames here, right side it is showing that frames, and loop. If I say instead of loop, if you just go for play once only or loop, so directly it will go for that particular number of operations. Okay, you can automatically speed. You can just say instead of 8, I just want to make it 10 or 15. It will be much faster. Okay, if at all you want to see slow, just make it 2. You can see slowly it is going. Okay, so this is how you can control the animations also here. So this can be also saved. You can see directly that time temporal things are all changing. So 19th April to something 15th June or something are chosen. So this entire thing is, so this application directly you can use it in your presentations, if not in your thesis. Thesis, because animated things you cannot print and then show. You can submit these animated files to your supervisors and things like that. This is one application where I'm showing. As I told, another application is along the cyclone track, how it is being animated. All those type of things also can be cross-checked pretty easily. So that's one of the applications. I'm just closing it here now. And so that's one of the beauty with respect to the live access server. So I encourage all of you with all that principles of remote sensing, whatever is told, and the other sources of data that we have shown from our ground station, from our data repository, and then other web sources that we have shown. you can use our live access server to do analysis, to do visualization, to download the data, to process it, to print the required plots, and anything that you want to do. Okay, I think this covers in not 100% of the application, but I encourage all of you to go over this and then try to do lots of hands-on. And then if any doubts are there, please get back to us, please write to us, and then we are happy to answer. So if you have any questions, and if you have already put those things in chat box, I'll be now answering those questions. Somebody asked about can we access CDOM data or only SST? No. I think I have shown you an application only for SST. If you go to the data sets, if in the data sets CDOM data is there, automatically it will be projecting also. Let me take an application of ocean color. Okay, instead of here ocean color products are there. So if you see, if I just click on the ocean color products, you got OCM 1 and OCM 2. So for example, if I just click the OCM 2, diffuse attenuation coefficient, total suspended matter, chlorophyll A. These are the 3 parameters that is available. So CDOM is not there in this. So that's why you cannot visualize it. Provided if there is a CDOM, definitely you can choose that also. I'm just sample choosing chlorophyll here, just to show you that, like, instead of my entire application on SST, I can also show you one example with other product. So it is uploading here. See, this ocean color data is high resolution compared to SST data. SST is around 25 kilometers resolution data, whereas ocean color data is almost 350 meters data. So it's a very, very high resolution. So it will definitely take some time to refresh that particular page. So once that page refreshes automatically, you can do all the other exercises that I have shown you: zooming, subsetting, downloading, exporting. All those things can be done. So to answer your question, CDOM is not there in our products. If CDOM is there, definitely you can choose it. And okay, so you can see that our chlorophyll data set has come here. Okay, for this it is from OCM 2 is from 2011 onwards. So I'm choosing a different time period, say 2018. Automatically it refreshes for February 2018. You can see the full passes here. Okay, so I think that's the question, and there is one question on PFZ data. I'm not sure. PFZ data, we are not making it available on our live access server. That is available in a different web page where we use a GIS platform to disseminate the data there. Okay, because that is changing on day-to-day basis, and we generally give it to the fisherman community. So that's why those pages are completely set aside in a different page. So those things are not covered in live access server. So I don't have those data sets to even show to you about the PFZ data. And I answered about CDOM. CDOM is not there. Let me pursue if at all CDOM data sets is available from OCM. I'm not sure. If it is available through OCM, I'll just cross check with my colleagues whether that data can also be put on the live access server along with this data sets. If it is there in OCM 1, let me see. I think it's only OCM 1, only chlorophyll is available. In OCM 2, attenuation coefficient is also there, that is KD 490. Total suspended matter is there, and then chlorophyll. Only these 3 parameters are being chosen. So let me cross check. I'll take your question and then discuss with my colleagues, and then in case CDOM is also there, I'll definitely make sure that that product will be available on our live access server pretty shortly. Okay, so I hope we could reach the expectation of all the users, and if you have any further doubts, you can definitely get back to us. All our email IDs are there in the web page. You can write to any of us, any of the faculty, or if you don't have any specific mail ID also, you can directly write to the webmaster at inquiries.gov.in, and generally that will be forwarded to the concerned person who is dealing with the data or the product or things like that. Okay. And one thing I would like to mention before closing the session, after this, all the corresponding YouTube links will be made available on our website. And in case some of you have missed live streaming, you can definitely go back to that and then use this YouTube links and then play back and then start listening to all those lectures. So in case you want to revisit them, you can do any number of times. It will be available. We also make our PPTs available to the users for download along with the YouTube link. You can also download that in case you want to use it along with the live streaming or recording of our presentation. And we also send one feedback form along with few questions, because we like to cross check to see how many of you have seriously listened to all the lectures. So few questions based on what has been taught here along with the feedback form. Please fill the feedback form and also answer those questions, which will be sent through Google Forms and revert back to us. Those people who have sent the feedback forms along with those answers to the questions will be given the participation certificate. Please note that you need to fill and send both of them. Then you will be receiving the participation certificate. Okay. Thank you all, and also keep looking for our future courses. There are almost one course for each month starting from now. Next month we have on data management. Following that we have on ocean data modeling, ocean modeling. Following that we have got our OTGA courses. So each month we are having courses planned. So please watch our forthcoming courses link on the ITCO web page so that you can know what is being projected in future, and interested you can register for the same. Thank you.